All right, everybody. How are we doing? I hope everybody's doing well. I have just managed to get the links into the description for the presentation. So tonight, I want to do this as kind of I'll say hi to everybody first, and then I'm gonna probably have to restart the router. It's being slow. That and my wife, she actually has came home sick, which she's done twice in a decade, and she has flu symptoms. So she's taking a quick test that'll be done in about 5 minutes. So for the Rona, I'll have to check on her too. She's got all the meds and pillows and everything that she needs right now. So just wanted to let you know that's going on. So if I leave for a moment, that's what that's about. But so we have all the sources in the description if you guys are curious what we're going to go over today. We'll start by some hellos for about 10 minutes if you guys are watching the replay, and then I'm going to give basically a presentation going through some things. And let me tell you what that's going to be. So essentially, new research has come out from the Harvard School. Some of it has been done by doctoral students in their free time. Others has been sanctioned and funded very well through pharmaceutical companies and through all sorts of different research. But there's a group that meets at Harvard. There's one at Yale, one at Stanford, and there is another one at Cambridge and both Oxford, I think, also have clubs, and they're all working together. MIT is the other school, and they're basically, whether it's legal or not where they're at, they're doing testing on psychedelics. And I already know this stream will be demonetized and it will probably be shadow banned. So if you guys do enjoy what you're seeing, thumbs up, share it if you want with anybody who would find it interesting. You'll have to see if it's interesting first. But also, subscribers welcome also. But I think most of y'all are already in that boat. So thank you for being here and being a part of the channel. Members, even more so, thank you so much for letting me do the research and spend the time on these subjects like this. So I want to make sure everyone can hear me and everything as is. Am I coming in pixelated or any of that? And let me take a look at the actual real chat here. Let me know if you hear any feedback or anything. But what we're going to be talking about at first may not seem connected, but it's very connected. And what one of the age-old problems we've had in science is how to quantify qualitative data. So quantitative data being there were fish in the water. How many fish? 5 of these fish, 3 of these fish, 10 of these, half were babies, whatever. That's pretty easy. But when you say, how was the health of those fish? Then it comes down to each fish, and it's either healthy or not healthy. What if you're studying degrees of lead poisoning in their environment? Well, then you have to do biopsies on the fish or whatnot, or necropsies, and then it's a scale. So that's quantitative too. So you can turn something qualitative rather than asking the fish how it's doing. You can look at specific aspects. But sensory wise, we've been at a loss for a long time. And what these clubs have done is they've gotten PhD doctors in geometry, in quantum physics, to take psychedelics. And basically, they've also had evolutionary biologists and anatomists, quantum physicists, like I was saying, are a big part of this. But what they've been doing is they've been taking psychedelics to allow them to hallucinate. And they're trying to explain in a quantitative way that qualitative experience. So it's easy to say, I'm seeing purple monkeys, I'm seeing this or that. But especially on higher doses of psychoactive chemicals, you start to lose track of that. And in this talk today, we're not going to go into the woo-woo, like I can talk to plants and earth and any of the spiritual stuff that I know a lot of people do find to be helpful, true, or even a part of their religion in like the Native American church or South American peyote and ayahuasca and other psilocin and psilocybin based, I guess, ceremonies. So what we're going to talk about is going to be that interesting way that they've broken down how there's actually an evolutionary and biological reasoning to why we hallucinate what we hallucinate. And some of it is not understood by your average person. But when they gave it to people who have been studying things like impossible geometry, stuff that could only happen in a different dimension, for instance, they're able to visualize that in their brain. And it's kind of like an MC Escher puzzle where you've got the staircase that goes up and then down and then up and then down endlessly. And they're finding that in certain dosages, people are able to see that. And unlike people in the past, there's actual levels that they can split that dosage. And it may be you're a small person, so it's not equal what 1 milligram does this in every person. So it's not equal. And also, by the way, I see the super chat by A Ticket to Space, and thank you so much. I appreciate it. Definitely lets me do more of these deep dives, less of the side gigs. I can spend more time on this. So thank you very much, my friend. No message on that, just $10. Thank you so much. So in any case, I'll probably be going to be missing questions at the beginning. But if you guys, when we're about 40 minutes in, probably, if you guys have questions, then we'll talk about it. Okay. But the interesting thing that's going on here is, hey, and welcome as a member, Dr. Anthony. And also to the Hector, welcome as well. And thank you so much for becoming a member. It really does help a lot. So thank you guys. So in any case, let me go back to where I was at and say that so with these quantitative ways of talking about qualitative experiences, we're looking at things like the possible ways that humans see. Well, we only have so many cells in our eyes, that can do certain things. So we're not going to necessarily naturally be able to visualize what it would be like to see heat. But we've created machines like sensors. So we have things like night vision and infrared. So we can use, there's not really another word that fits it, but these bionic accessories that allow us to, and I'll explain the thumbnail too, Ricky, that allow us to imagine or to then visualize what that would look like. And sometimes when hallucinating, people can actually think they're seeing those things. Well, then comes in the question, what senses are actually senses that you can develop? So for instance, people, there was a famous tattooer and body piercer, and he sewed neodymium magnets into his hands. He inserted them in there under a silicone pad, and over time he could sense which way was north by a tingling in his fingers, and they could test him on it. And they actually did a couple papers on this guy and everything. But it's interesting because that's using touch to explain another thing, which would be the Earth's magnetic field. Yeah, I was going to say, Dr. Anthony, I thought you remember, but thanks for renewing the credit card. I've screwed that up a few times and then realized, I haven't been a member for 3 months. I forgot to renew this or that. So thank you. I appreciate it. So what we're going to be doing is going over some of this research and some of this work that's been done and there's an hour-long video in the community tab on my page all about the DMT side of things if you're interested in that deeper human discussion. But we're going to go over kind of the basics of it and then tie in some new research they've been finding about animals, but specifically fish. For instance, they first found out in snakes that their heat pits in their, and also their Jacobson's organ in the reptiles that have it, where their tongue's flicking out and constantly getting air and molecules of things in there. Even when they take out their eyeballs and their optic nerve, their visual cortex lights up in the MRI. So they're actually overlaying something over their sight. And we don't know whether it's, a purple field and it gets bright purple where there's the rat that they're smelling, that it's food, or whether it's something completely that we can't explain. But I want to talk about some of the things that fish can sense. And then I want to talk about what we can maybe take away from this and where it's headed in research based on that. So one moment, I need to check on my wife, then we'll say hi, then we'll start the show on the road. So I should be about 2 or 3 minutes. But Mark, thank you so much. Again, thanks for the interesting subject. Mark Sterlson says, so thank you very much. $10, I think this Australian super chat. So good day or good evening, probably late at night for you, huh? Early morning. So I'll be right back. I just have to see if her test was positive. And if so, I'm probably about to get COVID too. So hold on, be right back. All right, so sorry about that, guys. So turns out that it looks like her test is negative. Yes. So it's the first day she's feeling sick, but like I said, in 10 years, she's never come home sick from work, except for once when she had, maybe a tooth and influenza. I think she's done it 2 times in 10 years that we've been together. So I was pretty worried when she came home in the middle of the day. But let's get to it. Let me see who all's in here. I do want to acknowledge you guys before we hop into this mind-bending subject. So it looks like we'll probably both just have normal influenza coming up. So anyways, Yancey, welcome. Ticket to Space, obviously. Mark Sterlson, obviously. You guys are both right there on my screen. Lady Diane, here, Fishy, Davo, Craig, Chris, Dr. Anthony, Brian. What's going on, Brian? Been a great addition to the community lately. Really appreciate it. Paul McCarthy, what's going on, my friend? Ricky, Isaac, Sketty Nona. Who else do we have here? New Local Austin, Wayne Talbot, Lady Rorschach, Mick M, Sage, Pharmacology. Ooh, I like that name with an F, not with a PH. Cute. Love it. Dee Dee, what's up? Lazarus the Fish Boy. Make sure your parents say it's okay to watch this. Regina Phalanges, Rock Hard Tanks. And let's see. That's who I see recently speaking up. But to everyone, Dragon Lair, I see you also. Isaiah, Knight Rider, Hector, Foreshore, Nola Dolls, all you guys. Thank you so much for being here. And strap in. Chris Howell also, and Giuseppe also from Kissimmee down in Florida. Right on. We got a lot of Florida listeners and watchers and doers and thinkers and movers and shakers and groovers. So let's get this show on the road. Let me pull up the first stuff I want to show you guys. So, like I said, all of this is peer-reviewed science, and some of it I'm going to actually, to start off our conversation, I'm going to talk about how fish see, our current model of it in a very layman's way. So there's actually a news channel that picked up a story on how fish see. Like, basically it was on, does it make sense to buy bright color different baits and things? And they touch on just enough that I think it's a good summary in a quick read to read off to you guys, and some pictures and things. And we'll start there, and then we'll go to the visualization and talking about the research that Harvard's doing. And then we're going to loop back and talk about information theory and geometry, and how when you have small amounts of information, things are very orderly. A dot, no dot, a dot, no dot. It's very simple, like binary. When you start getting into complex patterns, things that aren't patterns, things that are complete just random chaos, that's the other far end of the spectrum. And our brains in humans have evolved really well to pattern solve, to do certain things. And a lot of what we perceive, none of this talk today is going to be, none of it is going to be, I don't want to disparage any communities or anything, but it's not going to be Sedona Energy selling you crystals at a shop for your aura. That's all fine if you want to do that, but I keep an open mind, hopefully, and then go with what we have peer reviewed with people who are considered experts in it, in a cross academic way. So in cross field pollination of ideas. So the way we sense things and our limitations, and the way we organize information. So, and the way studies at Harvard done by Walter Bishop. John Monroe, what's going on, buddy? So I think it's gonna be cool. Some of this stuff is kind of trippy, and you'll have to kind of stick with me. But as I said, none of this is ethereal, not documented. I'm real big on having sources and peer-reviewed sources, because anybody can write a paper. There's lots of crazy doctors like Dr. Anthony who are just rogue mad scientists. You can't trust them ever. Rico Stan says, "Oh no, he just checked to see what condition my condition was in." Ooh, oh yeah. Got to see what condition my condition was in. All right, let me open this and get it shared. Thank you for the super chat too. I really do appreciate it. I really want to sing that whole song, but we're not going there today. I'm going to resist, I swear. On the trippiest talk, I'm going to try to hold it together the most, right? Not a groupie, but a grouper. I love it. All right. So I'm going to share this article. And get out of here. And hopefully you guys can see the photos that are attached. Let's see, are they embedded in the article? They were on mobile, but they might not be. So let's look at the photos real quick first, if it'll let us. Okay, so the first photo, well, that's a fish. That's not helpful. Next photo just shows you the orientation of most non-predatory fish's eyes. And even predatory fish tend not to have our same vision, which is binocular overlapping. Most fish have evolved to have two separate fields of vision, and depending on the fish, it can go to different parts of the brain. So it's usually a crossover. So usually the right eye goes to the left side of the brain and the left eye goes to the right side of the brain. So when you have monocular vision, you have a blind spot in the front, you have a blind spot behind you. We have the blind spot behind us, obviously. But then you also have an image out here that the left eye can see an image here. So the whole way they are experiencing the world is incomplete. So it makes sense that on fish, if we go back real quick, actually, they have a lateral line. And on that lateral line, in most fish anyways, some have a split one, some have a broken one, some have incomplete, or I don't know, maybe I'm trying to think of one that doesn't have any lateral line, but I think most fish do. I'm sure there's exceptions, but they have these little sensors all over their side, and it's an organ that allows them to tell how deep they are in the water, if there's movement in the water, and sometimes like in mormyrids and things, it could also be helping them to understand like the salinity of the water, the conductivity, the actual electronic signals and waves in the water. And for that matter, a lot of times we think that fish are very ancient and that they're simple because they had 450 million extra million years since they branched off with our common ancestries, evolutionary wise. And we think, well, we're 450 million years where they left off. But evolution never stops. Sometimes it gets pretty optimized and stays pretty static for comparatively, like say alligators, but they're not identical to the way they were. And fish are definitely not. We can see in cichlids alone how a few 100,000 years in the Rift Lakes is enough. And even, I mean, honestly, when you look at sticklebacks, even 50, 60 years is enough for them to change color, to change their spike height, to change whether they have armor plating or not. You guys can go watch my stickleback videos on that. It's fascinating. And this summer I will be continuing my research on surveying sticklebacks. You know, sticklebacks that are in silty water, they have, they tend to be colors that are murkier, browns and greens, and their belly is always silver. Whereas if they're in clear water, sometimes their bellies are blue and sometimes they're silver or green or different colors, but on top they may have crazy patterns. And usually if they're in the grass, they have patterns like a tiger. And if they have, if they live in the sandy area with rocks and stuff in the shore where there aren't a lot of plants, they have dots. And when they have, like, what do you call it? Open water, I guess we call it, living in a lake. It's not quite open water, so, but we'll call it pelagic for today. They have kind of like these waves and ovals and oblong shapes. And so fish can evolve not just with their DNA, but with their epigenetics. So that means that they have all these tricks that they've evolved to learn over millions of years, and we do too. So epigenetics, in case you guys don't remember or you weren't with the channel and haven't heard of it before, just real quick, we'll touch on that too, because it's fascinating and it kind of ties into this today. But so epigenetics is, say when you are a kid, you're born with one set of DNA, you've got genetics. And then you go, when you're a sub-adult, when you're a teenager or pre-teenager, you have a change. And your body has this map genetically that says, you are now going to start growing hair places and getting tall. And your voice, if you're a guy, is going to get deeper. And you guys know all the changes. I don't have to go into the birds and the bees. But all those changes start occurring. And yet you are the same genetically, but you change so much. And same with old age. You know, things happen just because of cell death and cell renewal and different processes in the body that break down. But there's also things like menopause and other things where things just change. And that's not necessarily your DNA changing. it's biological, and in some cases, what we call epigenetic cues. And epigenetics is basically an on or off switch for things in your genetics. And so when we have this, we have a really new field to study that's very hard to study because we have to have it, an example of it switched on and off. Well, now what they're doing with technology like CRISPR, that's CRSPR, little r at the end usually is how they stylize it. They're able to tweak these things on a pretty low budget compared to the past, where it was, you know, millions of dollars for these projects. Now they're sequencing genomes and uploading them in days rather than, you know, in years, like whatever it took 17 years to do the first human genome to fully map it. But in any case, so these genetics turning on or off, the gene is still there. It's still going to get passed on genetically, probably. I mean, just as likely as ever. It depends on if the mom or dad passes it on in the end. But the gene that might be in a fish that says you have spikes on your back, turns out that gene may have certain environmental cues that it's evolved to know. So it's not just selection of the fittest. It's not just evolution and the ones dying with the biggest spikes when they're not needed because they took too much of their metabolic energy to make these spikes, and they're not needed, versus in maybe a lake where eagles hunt them or bass are eating the sticklebacks, the ones with the spikes live the longest and then get to reproduce. That's typical evolution, right? But the new twist on that is that it doesn't take decades and generations of that. It can happen in one lifetime if that species has encoded in it an epigenetic trigger. So it may be that when the water becomes brackish, for instance, we know this in some species, they start to change how they metabolize things, how they absorb water, like salmon and things. And there may be a long period that this takes. There may be a short period. But either way, it's pretty fascinating. And when we go back to the story that we were looking at here, the fish have probably evolved other ways of sensing. So they've got their lateral line, they've got sinuses, air bladders, all sorts of things that they've evolved, plus just the feeling of touch and pressure. And where their vision is lacking, it may be that they have full vision like we do, but that the visual cortex has made up for this missing cone here that they can't see, and that it connects it. So they could see better than us for all we know. We don't know. We need to find out for sure on that. We just don't know. And so here is something I also want to show you about fish. And this ties into my last video, which was about Lake Inle. And Lake Inle is a shallow lake. I talked to Dr. Anthony Mazeral about this, and he and I mean, I totally caught him on the fly, and that's not his specialty or anything, Lake Inle, but almost every fish in that lake has red on them, and the lake is only about 12 feet deep. Well, look at this. It's a useful color to around 15 feet deep, and then you don't even see it anymore. The wavelengths of light don't travel through water well. And then orange, then yellow, then green. So there's reasons why, you know, black and white and other colors are on fish very bold oftentimes, and why red is usually found in fish in shallower lakes or rivers, or during spawning when they're in shallow water. And so you'll notice this even in an aquarium, even in 2 or 3 feet of water. If you look down at a fish, or if you're near the shore and on a dock, you'll lose all the color details in this order. And you know, it applies to every color. But the next thing I want to tell you is that fish have also evolved the ability to see ultraviolet in many cases, which is something we don't see. And where fish have pigmentation, like this fish here has pigmentation to give it stripes and the green versus the silver. Well, that silver that is in most fish scales, or even just the flesh of most fish, that silver is made out of little teeny crystals made out of guanine and guarine, mostly guanine, which is a building block of DNA, ironically. Very simple, basic biological building block compounds. And they form crystals in the skin at, the size of, we're talking down only maybe 50 to 300 molecules in size in some cases, but they stack in a pyramid or in a hexagon or in different shapes. And then when light goes through them, they're an actual crystal that's grown in the skin of fish. And that's why fish are silvery. Well, they reflect UVA and UVB light. Well, we can't see UVB light. And so, things like polarizing lenses and things, fish have evolved to see that because it makes sense. And guppies, when you get a guppy, for instance, that's really shimmery and it has like different colors and different lights, that's the iridophores. The chromatophores are the color that you see under that are the pattern. And if the fish, if were to be descaled in some case, sometimes it's on the scales too, but it's usually chromatophore cells or they have other names too, but that give them that base tone, and the glittery iridescence is above it. Now, some breeds of fish, some lines have been selected for it by humans in just the last 100 years or 50 years, really, like guppies, where you can get a totally shimmery betta, like a cellophane betta, a cello betta. They may look like opal. They're so shimmery, but they're white, they're albino, or they're leucistic, or whatever it may be. That means they have none of the pigmentation, but all of the little crystals all over their body. And it's literally little sparkling crystals, which I think is just really neat. So back to this article, the overview is basically ask most fishermen the color of their fishing lures and if it makes a difference. And the resounding answer will be yes. But ask a scientist and you're likely to get a less enthusiastic maybe or sometimes. So let's examine how fish see underwater, where visibility usually is limited to dozens of feet under even the clearest conditions. I mean, they're basically talking about freshwater there too. There needs to be there is little need for long range vision. Fish have been described as being nearsighted and can probably focus on objects much closer to their eyes than humans can. So they casting a popping bug near a school of bluegill, and one of them will often approach within an inch of the lure to inspect it, something that would leave an angler, you or I, cross-eyed. Even when fish first detect an object off to the side, it will usually turn and face it in order to examine it. Why? Question mark. The likeliest explanation is what brings us to the object within the narrow range of the fish's binocular vision. Unlike humans, many fish have their eyes set far apart on either side of their head. And that happens to be a predator or prey feature most of the time. Predators tend to have eyes in the front, or at least omnivores do, whereas prey, and this is a general all animals things, fish are less like this. But if you look at, say, a barracuda or an Oscar or something that eats a lot, a red-tailed catfish, they'll tend to have less of a blind spot in the front there and more depth perception with overlapping binocular vision. You don't have depth perception with just one eye, at least not as accurate anyways. That's where things like pressure waves and having a lateral line can really help, because it may be that something bounces off. We're going to pretend this picture of a cop car is a fish, but pretend this sidewalk is the lateral line. It may on the left side of the fish all of a sudden sense something, and then it turns to see it to confirm the size, but it knew something moving with a certain amount of force or whatever was there. So the front binocular vision encompasses only a 30 to 45 degrees of their vision. For this reason, some experienced anglers believe a fish is more likely to spot a lure if it is cast to the side of the fish instead of directly in front of it. Once the fish spots something, they turn to face it, and undoubtedly it gives the fish better estimation of the object's distance. Even though fish will turn and examine objects, their eyes do have limited independent movement within the sockets, just like humans. A fish's eyes move in unison, though, when they look around. And finally, a big question facing anglers and lure manufacturers the world over: do fish see color? Yes, they do. In many cases, fish see color vision probably comparable to that of humans. So you can justify purchasing Uncle Joe's bass slayers in all 32 available colors. Like those of humans, fish retinas process both cones for color vision as well as rods for black and white vision. That's a general statement. I will get back to that. During daylight, fish. This bit is interesting, and I don't encourage you guys to use news articles as sources for anything. Usually the anchor has no idea what they're talking about, and they interview an expert, and if they didn't get context, they fill it in and it's incorrect. That's very common. But in this case, this article was good, so I just, based on other research and info, I thought it covered it well. So fish use primarily cone vision in the day. At night, they use rods, which provide much higher light sensitivity and resolution. The process switch between using cones instead of rods and then back again can take up to 2 hours. And in a predatory fish whose eyes adjust quicker than littler foraging fish, they will have a visual advantage during dawn and dusk. At least one reason why these times usually provide best for fishing at dusk and dawn. Sharks, interestingly enough, though, do not see color, and they evolve very differently than our freshwater fish. Just a note of that to you guys. A very important factor in fish color vision is water depth. Water absorbs or attenuates different colors of light at different depths, affecting which colors are visible to which fish. So like I was saying, Lake Inle is only 12 feet deep on average. It's this big, shallow lake that's ancient, but red can be seen in most of that lake. So why not use red? Red is an easy color to metabolize out of pigments in their diet. Carotenoids have an orange or red color naturally to them. They don't need to break it down or have other chromatophores like blue, which is usually made with anthocyanins in the diet. It doesn't need to find those in nature, like blackberries, blueberries, or synthetically metabolizing them somehow to make the color purple, for instance. So actually fish like guppies and cribs and things, when they have a bright color display that's constantly changing, when they can spawn in bright purples and greens and things like that, plus be shimmery, it takes a lot of metabolic energy, and evolutionarily, it's also taken a lot of risk because they stand out like a sore thumb and can get eaten. So remember, there's a cost to these things, and today we're talking in evolutionary terms. So once we have this baseline down, then we'll talk about why psychedelics apply to all of this so well. So the particular depth of a red lure will no longer look red, but might appear as black or brown, while a green lure at the same depth may still look green. At even greater depths, color are no longer visible at all, and fish probably see objects in varying shades of gray. It is therefore not surprising that within both fresh and saltwater fish, shallow-dwelling species have better developed color vision than deeper water fish. And of course, water turbidity that inhibits light penetration greatly reduces the depth at which a particular color is visible. Despite that fact, red is the first color to disappear from the underwater spectrum. Some researchers have shown that red elicits the most strong reaction from largemouth bass. Okay, that's we don't care about that, but okay, interesting fact. Yellow was the next most important color for that species, and other research has suggested that largemouth bass also possess some better color vision among the common sport fishes, followed by smallmouth bass, muskies, northern pikes, rainbow trout, bluegill, crappie, and gar. So they're all either omnivorous or predatory of little other fish, maybe carnivorous in the case of like a pike or a gar, and then fishes which feed primarily by smell, such as catfish, may have poor color vision in comparison. So what's interesting about that is that new studies are showing that's not actually true either. There are catfish that have just fine color vision, actually, which is interesting. Now, corridoras and things like that, they may not. And that explains oftentimes in a species why you don't see bright purple and pink corridoras. There are exceptions. You've got some orange Venezuelan variants and things like that. But for the most part, you don't see these really flamboyant Loricariidae. You'll see hues of color. And so if you think about it, they're kind of dulled, even in like a blue phantom pleco, like any wild caught group. There's the ultra super reds and things like that in plecos, but really you're talking about humans bringing out a lot of those colors, whereas in the wild they're a little more subdued. So now that we've kind of got that down, human eyesight is very similar, and the eyes work on rods and cones, like we just explained in fish. What's going on, Jason? What's going on, Alyssa? Good to see you guys. And your rod vision is basically dim light and intense light, and it's kind of it's kind of like a grayscale, but it's not as simple as it's black and white and your cones are color, but it is overlaid with your cones. And some people are born without cones and they're colorblind, or they're born without one of the cones and they're colorblind. Now, humans, just like a TV, have evolved for what we need to see visually. And those cones are red, blue, and green. With those, just like on an old school TV set, you can create every color that we can see almost in the palette of reductive color, or of color that is combined. So if you have pigments and you're mixing them up, that's all the colors. However, when you have color that is created by light, like passing through a crystal, for instance, you know how when you add all your colors of paint together, you get black? Well, when you add all your colors of light together, you get white. Why is that? It's reductive versus adductive coloring theory, or basically on the new OLED TVs, for instance, or some of the LCDs now, they have diodes that are able to produce lots of colors, rather accurate to the color, and that produces a crisper color that we can actually notice. Now, beyond the typical primary colors you believed, probably red, blue, and yellow, you say, why don't we need yellow? And it's because yellow can come from red and green. It can also create a brown. So it's a little different because in our vision, we have light playing with that too. But if you look at a TV screen, it's going to be red, green, and blue as the colors. Now, if we really had eyesight that could see all the colors in the visual range of light wavelengths, and who's to say what the visual range is? As we just mentioned, some creatures like snakes can see infrared wavelengths of color, and they can do that because of a special organ. And as we said, when they cut the eyes out of the snakes and they remove them surgically and the optic nerve, so it wasn't a misfire or anything, they could use their heat pits in pit vipers to actually still navigate based on the heat radiating off surfaces. So now the color, the real primary colors we'll mention, are CMYK. And that's what we print with in the printing world. As a graphic designer, I have to know this too. And on websites and things, that's how you get the bright pinks and purples and turquoise. You can't get those mixing the red, blue, and green as vivid. So magenta is a color that's kind of added there. And as Yancey just mentioned, the magenta is a made up color. It's a trick in our mind. You can Google that for a whole other video on it. But the spectrum of light is something we've created in our bodies evolutionarily so that we can pick out colors of berries, probably. So you can tell when they're ripe, or you can tell when meat's gone bad, when it's red versus when it's kind of grayish pink or something. There's probably some reason for it. But basically, yeah, we have that adductive coloration that you see when there's light being projected onto something. And then you have the other kind when you're adding colors, pigments. And so fish, they have the iridophores. So it only makes sense that the fish also have a part of vision that we couldn't have, we can't understand, which is obviously light that reflects off them, or the light that they would see from UVB and UVA light. And UVB light, particularly, they see it, and a lot of predators go for that. And so that's why fish have evolved scales and schooling habits. If you watch my video on why fish school, it's an emergent intelligence video, or intelligent, not intelligent design. Don't get that confused. But intelligent systems and emergence is the other thing that goes into. But basically, it allows for the fish to look like one giant fish. So if a fish that's hunting it can't quickly process color vision, they're going to go with their UV vision. And that UV vision reflects, oh my gosh, there were like 15 little dots. Now there's one big glimmering dot moving as a chunk. And so it can deceive them into thinking they have one big fish on their hands. Now, sonar, it can work the same way. And most animals have then countered that by evolving ways to tell, like dolphins know that means, oh, they use echolocation. They use sound waves, which are all just waves, whether it's light, sound, microwaves, whatever. It's all just wavelengths and organs that have evolved to sense that. So there's that kind of evolution of sensory organs, and that takes in a lot of information. And then you've got the kind of sensory intake that is chematophore or chemical. And the chemicals are a whole other way of sensing the world. So really you've got vision, but that also kind of includes anything that you'd be coming in as a wavelength. So also feeling heat is its own sense, because that's actually a wavelength that then moves particles and causes them to heat up, for instance, or radiates heat and energy from one substance to another, conductive, convective, whatever it may be. But because of all this, I'm just trying to list out for you guys right now, before we get to the crazy psychedelic stuff, all these information flows that exist within a fish. And we may think that fish don't have good logic and reasoning, but for our brains, we can have something. And let me pull another thing I want to show you guys really quick too. Spinning Earl illusion. And I want you guys to try something and give it a go. This will take about a minute or two. And let me share the screen with you once we get this going. All right. So let's see if we can get this centered and everything too. Let me stop sharing this screen and remove that. Okay, share. Okay, so let's see how this shows up for you guys. Can you guys see this okay? You might need to get close to your device for this one. And we're going to go full screen. And what I want you to do is see which way it appears that this ballerina or woman, whatever, is moving to you. Is she moving clockwise or counterclockwise? So get that in your head. And then now I'm going to tell you, you may have seen this before. Now I'm going to tell you, put your hand over the screen and cover everything but the very bottom of her lowest foot. And then try and think, focus on it hard, and try to get her to spin the other direction. She's actually spinning both directions because she's a silhouette. And so if you put your hand over her and look at her foot, and after look away from the screen after you've been staring at it going one way, and if it's going clockwise, that's the way it does for me too. But then tell yourself it's going the other way and focus on it. Look at that bottom foot and try to see it going the other way. So it stopped. I'll play it again for you though. And what my point is here is these are all perception tricks. Now, some of you, it'll happen immediately and you'll be like, whoa. Some people might be like, I don't know what the heck you're talking about. But if you see it switching, please put it in the chat. Some people, their brain is good at this and they can make it go back and forth, flip between going clockwise and counterclockwise both ways, and it can switch up very quickly. You get better at it if you do it over and over. So, okay, so you guys can see it. Good. So that's an example, though. What are we really seeing? We're not seeing anything spinning anyway. We're seeing pixels appearing in one spot and then not another. So it's all an optical illusion, but our brain has hallucinated that that's going on. We have filled in the blank. We have filled in the information from what our past experiences are. People, ballerinas, they twirl on their foot. They go clockwise or counterclockwise. Those are the only two ways she could be going. Really, the only thing that's really true about this is she's bobbing up and down and pixels are coming and going. And that, I want you to remember that you're hallucinating. And I don't know if you're sober, but I'm sober. So you're hallucinating while sober. There's plenty of things that do that. Now, the next one I want to show you is another one. Rainbow to gray illusion. Spelled illusion wrong there. Where is that one? There's a nice, easy, clean one that we can do here. Where did it go? I had a link to it, but it's not there. All right. We'll do this one. So stare at the black dot for 30 seconds. Don't blink. Lock on that black dot. Get up to that black dot and stare at it. Keep staring, keep staring, keep staring. There's colors on the screen. There's 1, 2, 3, 4, 5, 6, 7 colors. Keep looking at the black dot up close. Keep looking, keep looking, keep looking. Let your eyes unfocus and just stare at the black dot. Don't stare at the whole thing. Now, what's going to happen in a minute is going to be freaky. So keep staring at the black dot. I promise it'll be worth it. Keep staring, keep staring. And oh gosh dang it, this is one of those one of those mean videos where they didn't actually put the answer in it. Okay, I'll just get a static image for you guys. Sorry, that was such a waste of time. I apologize. I should have looked for this illusion ahead of time better. All right, does this one actually do it? Let's see. And I'll have to pull you guys into a new tab. I'm just looking really quick to make sure that it actually does what I promised. No, there's another one that's a mean trick. Hold on. I won't spend more time beyond this, but the better one is color bars usually anyways. But you guys have probably seen these things where it says, for instance, there'll be a color illusion where it asks you to see one tile and which one is darker or lighter. And for instance, in this, you'll see that right here, these appear light gray and these appear darker gray. Well, they're the same exact grays. It's just the context that throws us off. See? Boom. Boom. But they also have the color contrast type thing. But my point being, because of our rods and what we assume we see in our sight, we actually see different things. So do you think this blue, it looks a little darker than this blue, or this purple looks a little darker than this purple looks a little lighter? It's all just relative. And this is all, yes, it's, remember, perfect here, Fishy. So remember that one dress where the internet argued over what color it was? That is, oh wait, you guys aren't seeing, gosh dang it, you guys weren't seeing what I was seeing. I'm sorry, guys. It popped up a new window. We're over this, but needless to say, here's the last thing I want to show you in optical illusions, which is the famous, how does it have three ends but only two sides there? Well, it all comes down to the way it's drawn. So when you follow the line back, this line here goes to this corner. So then we want to find the next line. Boom. This should be an empty void, but it's a solid bar. So this is an example of impossible geometry and our brain trying to make it real geometry when really this should be the side of the circle. This should be the top of this letter N, sort of lowercase n. And this should be the negative space. But then they went and put a circle here and throws our whole brain off. So now what I want to show you guys is the Qualita computing group out of Harvard. And they've been giving people different dosages of DMT. And it's 5 they've been giving people 5-MeO DMT, which is the strongest hallucinogen known to humans. And they've been then also giving them nitrous oxide to intensify that even more, to throw it off. But let me get you guys out of this shared screen and bring you guys over into this shared screen. So fish aren't any different biologically than us. We have cognitive power to project hallucinations and things, but there's plenty of things we do every day in our sight and in our activity where we think that we're seeing something and it's not really there. We're filling in the blanks. We're filling in the blanks because it's useful. For instance, when you look at a table or your hand, you know it has a certain tone. You know it has a certain texture. Well, for the rest of the day, the rest of your life, when you wave your hand in front of you, your brain's going to assume that that color and texture are there because 99.99999% of your life, it is. But your brain saves using energy by making all these assumptions about colors, textures, shapes, sounds. In fact, you have actually seen your nose and your blood vessels in front of your face for your entire life. The blood vessels that are in your eyeballs, you see, but your vision has told you ignore that. It's useless. But people with head injuries sometimes will actually start seeing those, and it will drive them insane. And DMT, for those who don't know, it's dimethyltryptamine. It's a very common compound in a lot of different organic forms of life, from fish to fungi to plants to bacteria. But it's very common in higher order life forms, mammals, and things like that, as well as plants. And when concentrated, it interacts with a tryptamine receptor in the brain, and basically, for lack of a better comparison, when they see people taking this substance, they end up usually falling back. Okay, so let me step out of this and talk to you guys one-on-one again. I feel weird just showing pictures of geometry. So DMT, if you guys are still with me, thank you. Dragon Lair, not a nerd. Nerds would know about DMT. That's right. A lot of nerds do know about DMT, or microdosing and all those things that a lot of people are doing. But yes, DMT exists in us. For a long time, there's this whole kind of pseudoscience thing that surrounds DMT, and the Harvard School is trying to demystify some of that. But basically, DMT allows you to dream while you're awake. It allows your dreaming patterns in your brain, and then some. Electrically, when you dream, it's all different parts of your brain lit up on the MRI and on when they're looking at electrode feedbacks and mapping of the brain and the blood flow. And so what they're doing is they're using this strongest hallucinogen known to man, as far as its safe dosage and consistency, I would say. LSD is stronger microgram per microgram, possibly, but you can't come back from it quickly. You would have some long-term problems by taking comprehensive amounts, or equal amounts. So what they do instead is DMT is a crystal. They can vaporize it. You can't burn it, but they vaporize it. And then they breathe it in, and for a few minutes, usually about 10 minutes, you either start hallucinating, and we're going to go over this right now, the different layers of how hallucination goes, and then of how basically when your brain is active. And what I want you to be thinking about is between the fact that catfish have taste buds all over the outside of their body. They have different ways to tell if they're equalized pressure-wise, or if their lateral lines are equal on both sides, so they know if they're tilted one way or another. They have the light vision. Some of them can see UV light. So all these sensory inputs are coming in, and supposedly early on we thought, and now we don't know for sure, but we didn't think, because they don't have a cerebral cortex, which is where we do most of our thinking about stuff that's human. What am I going to wear today? Your cognitively abstract thoughts, things projecting into the future, making opinions. So all that stuff is in the cerebral cortex for us. Well, fish don't have that, so we thought they never evolved it. But now we're seeing, oh wait, they can memorize things. They can do simple math in some species that don't have that. Octopus can replicate crazy patterns. Cuttlefish can do crazy patterns. Now, those are cephalopods, but they're also finding, whether it's a chameleon or fish that change color, again, sticklebacks, they can change color on cue to match their habitat. You guys have probably seen it with different types of your fish. They can change color. So they need to be aware of what the outside world looks like to their evolutionally relevant predators and to one another in the same species, and then realize cell by cell that they're activating. You're going to look like a blade of grass, so turn dark pigmentally. You're going to turn this. I'm going to flex all my scales so that all the UV light reflects at the same refractory angle off the surface. And when I squeeze my body down, most of it reflects backwards and off away from me rather than right into the eyes of my predator, which is at 90 degrees from me. So there's all these things that they have to evolutionarily consider, and we don't think of that as intelligence, but it's like rubbing your head and patting your stomach and reciting the Pledge of Allegiance at the same time, or trying to put one finger clockwise and the other counterclockwise, at the same time, that kind of stuff. They're doing like 30 things at once in some species of animals. And so we're trying to figure out, how can they do that without a brain like ours? We have this big old brain that we've evolved that nearly kill our females to give birth, and that are a calorie suck. They just eat calories like no other organ. In fact, champion chess players and long distance runners use the same amount of calories in like a 10-hour chess match against chess masters. They'll go through the same amount of calories as somebody running in some cases, the world class ones, not you. We're all too dumb for that, unless we got some world chess players in here. But it's very interesting. So we got to think of all these senses, all these little organs that maybe we don't know what they do. Maybe it's how much poison to administer. Maybe it's the UV light coming in from the sun versus how much they think they're putting off as a school. Maybe it's how they're going to school. And we've talked about how you can get rid of a lot of this stuff by simple rules, and that's emergent intelligence. So instead of having to know how to act as a school where it looks really chaotic, but they're staying together, it's actually simple rules like stay an inch from the fish on the right, never go more than 2 inches away, go whichever way you want, but you always follow the fish that are ahead of you. You can go in front, and with a list of a few rules, you can make very complex, crazy swirls like birds at nighttime, like swallows or sparrows do, or like sardines do. And so that's part of it. But what I want you now to think about when we go back and when we look at the hallucinations, it's how we as humans have been organizing information. So I want you guys to think about, now that we know that fish have been using their taste buds, their pressure receptors in some species, some of these species, they've now proven it's in their visual cortex. So how are we going to be able to quantify how good something is? Or even a dog, for instance. Oh, they're 10,000 times better at smelling than us. Well, that may be that 1 part per million versus it takes 10,000 parts per million or whatever for a human to smell it, whereas a dog can smell the one. But if they don't have good visual mapping of what that means, you can't do anything with that information. So these animals have all evolved different systems. And just because we don't understand their system doesn't mean they're stupid, or doesn't mean that they don't communicate. Like mormyrids, we can't understand electrical signal wavelengths, whether it's a sine curve that's wavelengths like this, or whether it's I forget what the name of that other curve is, but the curve that is squared off at 90 degrees. But to them, that's like the difference between male and female calls. To them, they can send an electrical signal that goes through all the water, and all of a sudden, all of them stop talking with their electric signals. They listen, they pause for 30 seconds at this one noise in mormyrid species, in mormyrid species, the elephant nose fish, and all of a sudden, they stop. And the other fish that made that noise will then say one more thing. And after it said that thing, then all the other fish will start chattering again. So there's some really interesting things going on that we need to get outside the box, one, to think about. And I want to show you guys two. One, that this psychedelic analogy is something I want you guys to consider about how fish see, how they sense. The fact that their visual cortex, and this is a very visual thing, but it may be with touch too. You know, maybe they can tell what color it is through touch. That sounds like a crazy thing, but there could be neurofeedback that would do that. Maybe they can tell through sonar or through electrical signals that that texture of that surface is a certain reflectivity. It has a certain pattern, and therefore it's going to be yellow. Because remember, a color, when you see it on a surface, not from a light source, a color coming in is just all the colors are absorbed into it that you're seeing, and all the other ones scatter off of it. So when you see something that's yellow, it's everything but yellow. You're just seeing all the yellow reflect off. The rest is all scattered into it. So maybe they've memorized all the different textures in the biological world, and just by feeling, they would know what color it is, and they could map that out in their visual cortex. So that's an example. I'm not saying that's a true thing, but I want you guys to think about that. So then let me show you this chart that I found really interesting. Let me pull it up real quick. I just found this to be a fascinating subject. And I made a post about it. If you guys want to watch an hour-long talk, I have also, I think I included that link too. Let me double check. But in the description, there's links that will get you to all of it. And there's a great talk on more than I'm going to get into, but how these things were organized. And so DMT, again, it's a very, very intense hallucinogen. And as an example, I want to take this and share screen. The reason why my thumbnail is this right now, hope this doesn't do some like feedback loop that destroys like YouTube or something. But the reason why this is the thumbnail right now is because I used a picture in a system that basically applied what they think is going on in your brain to this picture. So let me show you something. I'm going to go over to my email, and I'm going to grab, one sec, got to grab my photos from earlier. But you can look at that trippy picture for a moment while these load. All right, so now let's see. Will this open a new window? Okay, good. All right, we're good. So I'm going to share now with you guys how I made this crazy trippy picture. But I also need to first get from the community tab post, which is right here, that says, let me take you on a trip. Right down here, this is the hour-long video. And then this, which we'll look at in a moment, has a really cool set of tools about hyperbolic geometry and what it is to see beyond our current dimensions of perception, and how these hallucinogens have allowed people who are already thinking in these ways, such as quantum physicists and things, have allowed them to see things in a visual way that you just can't see without your brain going crazy with energy, and your receptors basically send signals, and they expect that you're going to get this little dopamine or serotonin or whatever, and that gives you feelings of euphoria, and that communicates with cells doing all sorts of things. It changes things in your gut. Well, these very specifically start to just mess with the stuff that happens when you're dreaming, when you're seeing visually. And it'll take a cue that should be coming visually and plug it into your skin sensor, plug it into your sound sensor. Suddenly you're seeing sound waves of music. Now, a lot of this sounds like it'd be really cool. And it's only like that at low doses of hallucinogens, relatively speaking, because soon your brain gets so overactive that it's not useful. It starts to deteriorate the message. There's too much noise. There's too many signals. And you start feeling this, hearing this. There's like a million things in your brain going on at once. And we haven't evolved to handle that. So what I want to show you guys now is on the email, how I made that picture. I want to kind of show you how a hallucination is built structurally, which would tell you how anything could be built structurally, and like how a fish sees, for instance. This would be relative to that. So here is the original picture. Let me get you guys a full screen of that. Nice and scary. I had something in my eye the other day and literally just took a picture of myself. This eye's kind of red. Wasn't a good picture to see what was in my eye. But when we go into a software called Google Deep Dream, what happens, the first layer that it did is, oh wait, that's not the first layer. Here's the first layer. So the first layer it did is one of these layers where it started looking at all of Google's photos. And this is what our brain does every day. It looked at all of Google's photos that are shared publicly. So that's everything from a truck to a pattern to music videos to celebrities to dogs to cats to patterns, you name it. And it started analyzing sections of my face. And anywhere it saw a pattern, it continued the pattern. And there was a feedback loop. So if it thought it knew what filled in the blank as it scanned from side to side, it would fill in the blank with more information. And each time I ran it through the same filter, the patterns become more and more defined. So honestly, as someone who's used mushrooms and other psychoactive substances, I'll say that here. I'm not endorsing them or not disavowing them or anything like that. But this right here is very similar to a low level hallucination. You'd be seeing objects kind of breathing or swelling in size and contracting. You'd be seeing light. You see kind of like when you get out of the pool with chlorine in it and you see halos around everything, or when your eyes are really dry and you see like rings around street lights and stuff and it's dark out. Anything like that, you get lots of little things like that. Well, that's all in one dimension. With high strength hallucinogens, we start to get multiple dimensions that are morphing, and we start to get movement. So as I passed it through, so we go, this was one pass, then we go to, let's see here, to two pass through. See, we're getting more pieces, getting more complex. This was like 10 passes through the same algorithm. And Google has seen so many eyes in its pictures that it is assuming that there's some eye shape. It saw my eyes. It's assuming that, knowing the rules of if it had to draw a picture, it's assuming that anything that kind of looks like an eye starts to take on the look of an eye. And so you kind of get in hallucinations, all it takes, what they call this is a nucleation point. And you get a nucleus, which is something that your brain fixates on, like this eyeball. And then all of a sudden, there's eyes everywhere. That's all you can see. Well, another thing that's big on the internet is little furry cute things like cats and dogs. Instead, it looks like it started to make some sort of cute puppy up in the corner here. And then it saw fur and said, well, where else is there fur? And then usually with eyes and fur, there's a nose. And it starts getting into these deeper and deeper things until I find this fascinating. And if you guys know anything about DMT, look at this. There's like a little figure, a little creature in the background that looks very human. It has a bonnet or a hat. It has an outfit on, and then it looks like there might be like churches or buildings here with like the chapel, and maybe this is a doorway. And then you start getting all these interference patterns, which are just common patterns that happen. And so you can see, like, for instance, checkerboards is probably one of the most common patterns. Also spots. So you see snakeskin, like a snakeskin Endler pattern going on up here in my forehead. But this moving would be very similar to a high dose mushroom or LSD trip. And then you start to see things that aren't even there. And that's where really this research gets extremely interesting. And so what has happened is this guy, and I don't recall his name, it's a grad student, has basically created levels for thresholds at different dosage of DMT. And when you are at a low dosage, the energy in your brain, the electric energy, is active more so than normal. But the more you take, the more signals go insane. And that's going up on this chart. Whereas the information you're seeing and thinking about and signals being received is also increasing as the dose goes. So basically, this is explaining why, quote unquote, sacred geometry or nature geometry, fractal geometry, there's a lot of different names for it. The technical name for it is hyperbolic geometry once we get to the more Alex Gray looking art and beyond MC Escher. But essentially, you start by seeing simple patterns. You start making patterns out of information that usually we were taking for granted. Usually our brain assumes, oh, it's wood grain. Oh, it's my skin. Well, instead, your mind starts to wander and send wrong signals. And you may see plaid instead of wood grain, or the wood grain may start to flow like a river. And then as you have more information and you think about more, and they tell people, try to figure out this puzzle, they actually start seeing more and more detailed things and making out visualizations in their brain. They can make objects that aren't there, just like manifesting something in a dream. Now, all the way over at the edge down here at the bottom, this is useless. We can't do anything with this. It's just like watching a static TV, static on a TV, it's funny that it's called static because it's super dynamic. It's moving around, it's little gray dots, but it's just so much energy in every little spot that nothing makes sense. There's no order. Well, as DMT is, it uses those evolutionary patterns that we've been talking about of color and some of those perception tricks that we have talked about, and it totally goes haywire. And you go up the scale, and assuming that a dose is generally a linear thing, it's not, but I mean, assuming that it progresses, the more you take, the more it goes from the bottom to the top corner, bottom left to the top right corner. And he's named the stages and stuff. So I encourage you guys to watch the video. He's got all sorts of animations and things. But up here in this realm, this isn't super useful to what we're talking about, but it's fascinating nonetheless. So we're not going to talk about it. But this is where people around the world, whether it's tribal people that don't know anything about our drug culture, or whether it's math professors and, uptight folks that are never done a drug in their life and never, wouldn't consider themselves spontaneous, that have been in these studies for various things. And head injuries can cause some of these things too, but none of this upper level stuff gets caused in head injuries. Now, ideally, we wish we could take the information and the energy and end up with something useful. So we could be solving crazy math problems with beautiful intricacy using our pattern recognition and everything that we're used to. And you could follow from this. But right here is where we hit our first snag, and that is, this is very similar to fractal geometry. Start seeing these patterns, but within that, then you see these patterns appearing as 3D. When you're on DMT, oftentimes you'll take a hit and you'll fall back seemingly unconscious, just barely breathing slowly and maybe sweating and twitching a little. Everyone else in the room might think that you just passed out, but really your brain is firing so fast that your body doesn't even know how to respond and like locks up, assumes you're dreaming for your own safety. And so you get into these type images where and this is familiar with mushrooms and LSD too, where you start seeing complex geometric patterns forming, not just wood grain flowing and things breathing and colors being illuminated and switching and being kind of feeling more intense. That's another thing, is most people say they feel more intense. They feel like they understand a connection to everything or the universe. Well, what it is it's literally your senses blurring and connecting to one another. But what they've done is they've been able to chart this out, and they've been able to actually come up with cutoff points. So this looks like a square when you look at it from afar, right here where my cursor is. But when we look at it closely, it's not a square at all. It's all these dots and blue space and negative space. And within that, then you'd see flowing textures within each section. And that's where we get into this really crazy high-end psychedelic stuff, where you start seeing basically the stuff that you think of from cartoons, where there's creatures that aren't really there, that are speaking to you and things. And some people, many cultures, believe it's actually seeing a dimension or energy that is not of what we haven't evolved to know. And that's the only way they can commune with it. Now, I'm not going to comment on any of that, but universally, people start seeing humans or creatures that they recognize as something that generally start talking to them. You start forgetting that you're even a person, that you're hallucinating, and you just come back from it with a memory of being bodiless, floating in time and space, and seeing these crazy colors and patterns flashing before you. Well, for the longest time, we couldn't describe what was going on. People for a lot of times in the 60s and 70s, they'd look at MC Escher or tessellations, and they try to point to patterns and kind of trippy-ish looking stuff. You even go back to old architecture in Muslim tile work. A lot of it is like this stuff in the old mosques. Well, it turns out that some of the stuff that we couldn't think of and didn't have names for makes sense when you start looking at really complex systems like emergence, like heat diffusion, things like this pixelation. This is actually what we call Gaussian blur in Photoshop. And it's actually a mathematic algorithm that's going on. It's the magic eye algorithm that lets you see a sailboat hidden there or whatever. I think this one happens to be a lobster. But the point is, it looks like chaos until something clicks, and all of a sudden we see that it's a picture of something. And that's what happens on these hallucinations. Things come into clarity. But they've named them these different levels of how intoxicated someone is. And you start seeing more and more of what you project into it and what we've evolved to sense. And we project that into the system. So you end up with something real crazy by the time we've run it through just the same system with the same rules and assumptions 10 times over or 15 times over. I did this earlier yesterday. You end up with this from this. And so what is it that fish are seeing that, and here's a picture of brain scans, by the way. This is the brain wave function as DMT dosage goes up. The amount of electrical activity right here. This is if you weren't on anything. Yeah. And then just to remind you what DMT looks like, basically a rocket ship up and then a linear trip down. Whereas a normal brain thinking about something, closing your eyes or dreaming or thinking, It has all these different waves, your alpha waves, your beta waves, your LZ, your LZN. They're all monitored in MRIs, and then also in where they look at your wave, your electromagnetic energy in your brain, and communication and blood flow. And you can see massively different patterns occurring in different sections when they put the funny cap on with all the sensors. So all these waves of your brain that normally are opposite sides, like they stay on opposites. So when your alpha waves, like for sleeping and stuff, or being awake or whatnot, and your beta waves are right there going up, your other waves are going down. And so all these brain activities, when you take a hallucinogen, they start to sync up. They're all going up, 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 up in energy, and then they start to come down as you sober up. And different parts of the brain, like the visual cortex, just start glowing with activity. So what I want to encourage people to think about is, what is it that these fish and things are able to comprehend and able to understand that we cannot, because they've evolved systems like these to overlay information. Whereas if we were given their sensory input, we would end up with information that's just information overload, no idea what to do with it. So here we have a hyperbolic geometric shape where it's an impossible shape, where the inside becomes the outside, becomes the inside of a line, and then yet it's broken up in folded, and there's a pattern on every layer. Well, they found when they gave this to quantum physicists and to geometry math professors at MIT and things who'd never done hallucinogens, most of them, when they saw those things at high doses, they were able to come back. In the moment they were drooling on the couch, but they were able to come back and say, that's a hyperbolic paraboloid. And then they could graph the functions later. And then other people who had taken the substances were able to say, yes, I agree. And that was somewhere in between the low dose and the high dose. That's kind of medium dose stuff for DMT. And that's where, we just didn't have the words to describe it before. Very, very low dose, this is something that might happen. You might still see the world perfectly normal, but at the microdosing level, you would just see everything a little clearer. And this is an example, but it's not quite like this. If you've ever taken a substance, things are just slightly shinier or slightly more real. It's hard to explain. You feel like you've been watching a movie your whole life and someone turned off the TV and you walked outside and looked at nature for the first time. It's just because your neural networks and neurocircuitry is not used to used to it. And as it's getting these new experiences and new amounts of energy, they're finding that your body finds novelty interesting. So like when you go on a hiking trip and you go up and it feels like it's taken a while and you're looking at all the cool new stuff, the hike back sometimes seems really quick. Or it can be the other way. It can seem like it takes forever because you've already seen the stuff and you're like, I know what that is. I don't care. There's nothing surprising. So we're going to talk about this in a minute, but the next level up, I just want to share, these links are in the description. Next level up, you start getting these more and more complex geometric patterns. And then we start losing our ability to describe what's going on. You start seeing, not really patterns. It's so much information that our brain cannot form patterns. We haven't evolved to process all these things at the same time. Yet maybe a Corridora can sense pressure waves, can sense electromagnetic fields, can sense UV light. It can sense colors in its vision. Maybe in its visual cortex, it's able to see another whole dimension that is water pressure, or that is the barometer of the environment. So what's interesting, the last thing we'll touch on is, as you get to these geometric levels that are universal for humans, fractal geometry and some of this Fibonacci sequences and Mandelbrot sets start coming into play, which is interesting because the math world has been able to graph these things and show these things for quite some time. But here is another example of what you'd be hallucinating on a 3D sphere. And at the high levels, it's not there at all. It's all in your head. You're not projecting it onto anything useful. You're completely imagining. You're dreaming while awake with your eyes open or closed. It depends. But these are just examples of that constant flow and change of how things appear to try to give you somewhat of an idea. Then the final stage, the breakthrough stage, you black out right after this. Humans just can't process it. And this is that stage where people say that they melted and became one with the universe, things like that. This is where we see highly organized shapes start to reappear again, only to fully collapse and people to not remember what happened at the amnesia level. But it is interesting to me that people who have been studying geometry, who've been studying algorithms for creating 3D shapes and rendering in video games and things like that, people whose minds have been slowly adapting to understand some of these impossible or improbable worlds and surfaces and patterns, to them, they're able to come back from that trip and explain it. Whereas other people are just like, I don't know how to explain it. It was just so trippy. There were like boxes and colors. And so now we're actually getting a full-on way to describe things that makes sense. And we're actually finding that people are applying these things to productive systems. This is another great example of at the high doses before things cut out. Very frequently, people see clockwork or gears or mechanisms. And this is for people even in tribal groups that don't have a cultural context for the Industrial Revolution and gears and sprockets and things. But yet they'll report or draw similar things. This is, maybe something you'd see in a dream, and you're never going to replicate any of this near fully. But now we're starting to actually find ways to make useful tools and algorithms and structures out of some of these rules and layers of layering. So here we have, this is a quick little thing from a guy named Jitterbox, but just to show you how in DMT visuals, this is what he was seeing as a structural engineer. He was seeing something along these lines of a hexagon interlocking in a way that right now we don't have hinges that double back on themselves quite like that. And like the inside can become the outside and then can fold into a square again from a hexagon. Like what? Yet then he was able to put together with the 3D printer an actual shape with geometry that we didn't know about before, that can turn in on itself and do some of these things. And all this has to do with the flow of information and the use of it and being able to describe the information. So what is it that we will learn from our animal, from the animals that we study? I mean, what is it? How are they rendering these things? And will we ever be able to actually see what they see? It's kind of like that age-old question, is the blue you see the blue I see, or do we all just see a color and maybe your blue is my red and it all just works out because we've all been told it's the same thing? Well, now we're starting to think that evolutionarily, structurally, in humans, fish, that there's actually like a groundwork that makes us the same, unless you're colorblind or something else. But here's another example of impossible hyperbolic geometry. And it's like, how do you think up these things if you can't play with them, if you can't manipulate them in real space? And that's why they're finding these things to be so fascinating and useful. Lady Diane, thank you so much for the $20 super chat. That's so generous of you. Said, excellent stream, Alex. We love listening during dinner. Thank you so much. Well, thank you. Thank you all. So I want to know what, what you guys want to know, or what you're thinking, or if you have any thoughts on how these things apply, or fish might interpret the world, or whatever. And that's a really good point, Dragon Lair. So Dragon Lair just said blue wasn't a color till after around 2,000 years ago, and that's true. In most cultures, they would call it the color of the sky. And when the water was stormy or something, they'd call it wine. They'd say, "Oh, the water looks like wine if it's stormy in that like dark navy blue." If it was like a foamy green, they might say it looks like a creek. And then they would relay that to other colors. But nobody had a word for blue in any verbal language. It's always the last color added in every written language that we can document. Like, we can go back and see. It's always, you get the primary colors, then you get like the secondary colors. And well, first you get black and white, then you get the primary colors, and you get the secondary colors. That's true for almost every culture. Now, there's an Inuit group that has everything is shades of different colors. So it doesn't have to do with color other than red for blood, which is interesting. So it's not that the mix. So it's not that they didn't see blue or know what blue was necessarily, but just like we don't have a word for what is like in the color in between red and white. And most of us would say pink. Well, there's some cultures that don't have a word for pink, yet they may have specific words and clear delineations for. So let me tell you this, as an anthropology student before my archaeology studies, there was this fascinating study where they took a bunch of tiles, and all of them were the color green or red, and they were in a spectrum, and there were maybe 50 tiles in each set. And they took these tiles all over the world, and they said, "Do you have a name for this?" And so, they take it to an English speaker, and they say, "Okay, well, this is apple green. This is forest green or Kelly green. This is like a dark green, maybe I don't know, like a dark green, chartreuse, or neon green as the light greens." And then on the reds, they're like, "This is pink, this is crimson, this is magenta, this is whatever." Well, when they got to tribal groups that didn't have a lot of synthetic dyes and hadn't interacted a lot with any digital displays or anything like that, these studies were done 40 years ago now, but they found that they actually were able to take 50 tiles of green, and even if they didn't have a name for it, but oftentimes they had a name for like 15 or 20 tones of green and no name for purple or pink or some color that just didn't matter because it wasn't in the desert very often. And they just said it's the color of a prickly pear if it's only found on prickly pears or whatever. You can watch videos that explain it better than that, but I don't have quite the time here. And yes, women also see a better variety of color than men generally. And there are a lot of people who are considered super seers, or really what it is your brain's ability to see tones because you've found it useful or interesting culturally to use that. So in those cultures where it matters if the berries are this color red versus the next color over red, that might be diarrhea versus the vitamins and fluids you need to survive in the desert, and it's not ripe yet. So you need to know that exact red. Meat, you might need to know why, when it's gone bad, same thing. And we don't have names for how reflective things are. whereas some cultures have words for luminance. So if something is like a fish, shimmery, there's different qualitative levels of that. So they would say it's mirrored red, or it's, and we say like neon red to say bright, but it doesn't really mean the same thing as a actual neon light that gives off diffuse light. So when in these people, yes, orange is also a fairly recent color too, David. Thank you. Yeah. And purple as well. But in these people, and it's funny that purple came before blue in most languages to me, just because it's supposedly a primary color. But in any case, the green tiles, bush people could put them in order. The Kalahari bush people, the Kung Song, you're supposed to click, but I can't do it right now. I don't have any lower teeth. And then when they took it to the Inuits, they weren't able to recognize as many as, and it wasn't the Inuits actually. I think it was the Ainu people of very northern Canada. Inuits have a lot of contact with the Western world now, but at the time, northern Canadian and Greenlander tribes did not. And then they took it to, for instance, the Chinese person living in a farm area versus living in a city. Then they took it to someone who works on software on a computer, and someone who works in a paint factory. And what they found is it's a cultural construct. Color is like where you draw the line. There's infinite colors. There really are. It's just where you want to call the wavelength what's correlated with how we see it. Well, the same thing is true of every sensory experience. And so we're really trying to figure out qualitatively and quantitatively how you can change those things, like how we can explain the perception of something else when it's something we've never perceived or can't perceive. So thank you again. I saw another super chat also from A Ticket to Space. Thank you for the one at the beginning and the one here. I really appreciate it. We're coming up on the 2-hour mark soon. We're about an hour, 45 minutes in, 46 minutes in, so 47 minutes in. But I'm wondering, does anybody have any other questions or thoughts? Was this interesting to you? Do you feel like you learned anything? Did we go completely off on a tangent? Was that okay? This channel, obviously I love fish, but I really find all these things fascinating that we try to touch on the channel other than just fish. And if you guys don't mind, I like to continue to kind of tie these things in. Dragon Lair says, my Greek friend describes his orange flowers as yellow all the time. So yeah, it's very subjective. There's no truth to what color something is, other than if you were to write down the wavelengths, perhaps. But then it's still subjective to who the viewer is, and if it's reflecting off something, if it's projected light or reflected and absorbed light, scattered light. Vazaroth, well, I think you'll enjoy watching it again if you just caught the last bit. So, I want to encourage you guys to look for ways that animals sense things. We know the Jacobson's organ is snakes when they flick their tongue in the air and they're getting a scent of something. We know that they're getting chromatophore or chemical receptors, and that's triggering something in their brain. We juggle our senses. Some people say 5, some people say 6, some people say 12. I think technically now they're saying we have about 12 senses, because like pressure is a sense, heat is a sense, and then touch is a sense. Like they're all different senses, even though touch and heat kind of feel like they're the same thing. Like we've split them up, and who knows, we might split them up even more. But when we're thinking about our fishy friends, how have they evolved to see their aquatic world? And I think when we start thinking outside the box, and when we start thinking, What is the reality that they evolved for? What would be a useful thing for them to have evolved in the 400 million years we thought that they were just dumb fish, while we were evolving the ability to see twisting spirals and 3D craziness when we eat a certain chemical? What is it that they were able to do? For instance, the archer fish underwater, it can predict the geometry depending on the wind speed, what it's doing to the water optics, and the barometer. Even the pressure has a little bit to do with it, and how deep they are underwater. And then they're able, with that blind spot, remember they only have binocular vision in one narrow area, then they're able to squirt a stream of water and predict what it's going to do with the resistance of the water, with how much they have, and hit a bug on a leaf 5 to 6 feet away. I shared this for all you members. You guys got the this week's episode a day kind of thing. Technically, if I only did 3 of those a week, I'd still be putting out 7 episodes a week, if you count these live streams. And I think that a lot of times I connect things to that. So if you're looking for more materials, more links, like I put the links to most of the stuff we talked about today in the description or in the community tab, and then I pinned that note. But if you guys want to go down these rabbit holes, if you guys are fascinated by this stuff too, it's only $1.99 to be a member. I know a lot of channels want to charge $5.99 or $4.99 or $9.99 and this or that. And honestly, I can't promise you the world. I'm just asking that the more folks that help out at that level, the more that then I can do deep dives on this stuff and come back, spend my time teaching or sharing what I'm learning, what I've learned with you guys, and hear what you guys are learning and respond to when people write me and learn what it is they're saying. Because right now I'm at a point where I'm juggling, doing gig work, graphic design stuff and painting and things like that, and also doing the YouTube thing still, because it's hard. We got a house, and so that made things go up a little bit, which I'm very grateful for. But I don't want anybody who's ever worried about it. If you can't spare $1.99, please don't sweat it. Don't feel obligated. It's just for those of you who are saying, how can I continue what I'm seeing? Being a member helps. Obviously super chats help, but being a member, I end up getting about 80 cents to 90 cents of it to take home at the end of the day from each person. And that's a predictable monthly thing. So I can know that way, okay, I don't need to hustle because we're going to owe money this month. So I just want to say that, because this did take a few weeks of research to do this one live stream. And I know most people won't watch it. I know this content is not what most people want to be engaged with, but I know that there's people like me and you guys that are all here that are fascinated by it. And I want to keep it available. I want to keep doing it as much as I can. So let's see here. In the comments, yes, archer fish can shoot streams underwater too. Totally. Stunning shrimp and stuff. Definitely. Somebody asked me about the pineal gland and the third eye. So there's been some research on that, and I don't want to comment on my personal beliefs on any of it. From a scientific belief, I think there's a lot we don't know. I think it could easily be that there's fifth or sixth or however many dimensions out there, and other, in quantum physics, they say every moment, every billionth of a second, the universe goes into infinite possibilities of what could have been. And somewhere out there in an endless universe, every variation and permutation of that exists. So I think there's all sorts of interesting things that we can't explain. Science can't explain yet. But as for hard biology and evolutionary or repeatable experiments, I I haven't really read too much that's that conclusive. You know, for a while they thought it released everything as the same as when you see your life flash before your eyes. It's not. It's more than that. It's more energy going on in your brain than that. They had a guy just recently die with electrodes on in an MRI at 87 years old. I think he was Italian, and they were able to see that his visual cortex went insane, and he started, you know, something was going on, probably his life flashing before his eyes. um, but they can't say for sure what the visions were yet. We may get to a point where we can say he was thinking about something sexual, he was thinking about something food related, because, you know, this part of the brain lights up with this part of the brain, or, you know, so, but we're getting better at mapping all of that. And some people think that's great. I do. Some people think it's creepy. I do. And you know, I'll be watching regardless and reporting back. Um, Thanks, Wayne. Your videos are always spot on for learning everything in the hobby. Well, maybe, yeah, maybe pushing it all the way to the edge of what's even at all in the hobby. But I think it's relevant. And in my life, where I love fish and the hobby, these are things that I think about when I read a study. I'm like, man, that reminds me of that one time when I took mushrooms 20 years ago, and, you know, the pattern thing, I could see why pattern recognition would be an evolutionary thing, and why you'd project that, and why that's why fish assume that a mirror image is not, it's not the same as a refraction that moves off water, and it's never perfectly still on water. So if they can sense that and they see a perfect mirror image of themselves, they'll attack the glass, you know, or whatever. I'm just making something up off the top of my head, but, you know, I like to see how interdisciplinary things work into our hobby, work into the science of biology and evolution. So I think I'm probably going to get off of here pretty soon. Do we have any other thoughts? I see people saying lots of great stuff in the chat and everything. But I'm going to try to hold off on answering like too many non-related to this video questions, just so we can get them taken care of in a timely manner. But if you have questions, like if you have a health issue with your fish or something, put them in the comments, and I'll try to get to them. I think all of you guys know by now, I spend at least 5 or 6 hours a day responding to y'all. So I'll try to get to your comments and questions. And if not, I'm sure someone else will also try to help. Yes, I have read Holographic Universe, and I do know about different things like the projection theory and the holographic universe theory and some of that stuff. But I don't feel qualified to teach it. I could brush up and teach an aspect of it, but yeah, I've always been very interested in quantum mechanics, quantum physics, and kind of philosophical mathematics, if that makes sense. Things where the possible meets the impossible, where biology meets psychology and culture and all those things. Sunset Jen says, I keep looking for all these things in my aquarium. Well, right on. I mean, that's the hope, is that, you know, you come here, you get your brain tickled a little bit, and maybe you will look at your tank a little differently. So let's see here. Upper Aquatics, Powerhouse, I've got more thoughts, but I'll leave them as a comment. Sweet. Yeah, feel free to leave a detailed comment, guys. I love that. And if you enjoyed this stream, again, it's gonna get shadow banned. If not, like, I mean, it'll get demonetized. I'll get super chats, but it'll get demonetized, and then it will still run ads, and Google will get the ads. But you know, it's because of the word psychedelic, and because I think I said drug and COVID too, because of my wife at the beginning. We're gonna get, this one is not gonna travel far unless you guys want it to. So if you guys had a fun time, if you guys like this, I've had past videos about like the Fibonacci sequence or the Mandelbrot set, and how it like matters to how fish scales are laid out, and pine cones and sunflowers and mountain ranges, all sorts of things, veins. And I might redo some of those if I can get like maybe someone can illustrate it, or I can get the rights to clear using someone else's illustrations. But yeah, that's somewhere for the channel to go in the future, you know. Let's see here. Well, Michael Allard, thank you so much for becoming a member. I really, really appreciate it. I do. Thank you. I look forward to you in the community. Let's not. Yeah, I see you guys going on there. We're gonna stay on course tonight. I'm not gonna go down that rabbit hole tonight, but I have been that has yet to resolve itself. There's been no proof added to my database. In any case, guys, thank you so much for joining me. I'm going to wrap it up here. I'll probably give it a minute as I wrap it up, just in case someone has a last minute, like, oh my gosh, I need something. Seems to happen. But if not, I am going to call it a night, and I look forward to reading the comments on this one. And I'd love it if this did get handed off to a few other people, just because I know, you know, usually the live streams seem to get 1,000 to 2,000 views, and this one, if it gets shadow banned, you'll know, because it'll have like 600 views. We've already had over 400 people coming and going total throughout the stream, so it'll be interesting to see how much they don't like this being talked about, just because it's illegal drugs. Even though that's not really what the heart of all this is about in any way. And DMT is in almost every plant and creature. So like you're technically in possession all the time. All right, guys. Well, oh, wow. Michael Allard, you upgraded your support. Thank you so much. Really, honestly. Even better. I appreciate it. And if you ever have questions and ideas for this goes for all of you, but especially my members. I really, really value what you guys say. If you say, Alex, you're slacking, or you are not providing what we came to know and love, or I want to know about this or that, and you haven't touched on it, just let me know. Like, we're here to learn together. I may not know about it. Maybe I can get an expert who does know about it. The pineal gland, anatomy of the brain, I don't know a ton. I know some. I've had a massive brain injury myself 4 years ago now, almost. And so I do know about some of it. And also I have altered some of my whatever. I lose words a lot. So DMT did not kill the eagles. That was DDT, which was a pesticide. But I can see why you get that switched around easily. Yes, please do not give psychedelic substances to your fish. They're confused enough already, I think, by being in a glass tank. Do not give any substances that are mind altering to anybody other than yourself. If you're an adult and you've done your research and know the precautions, you've taken the precautions and you know the implications of such actions. So thank you for wishing my wife a quick recovery. I hope I'm not the next, but if so, I might be MIA for a couple of days. But I'm gonna get out of here, see how she's doing, and I just want to thank you guys for hanging out. I know this is kind of a lecture-y talking at you night, but I hope from here we've got a baseline, and anyone who joined us here, now we can talk about any of this in the future, and people can send me articles, or I can touch on it again when something comes up. All right, guys, I will talk to you later. Have a wonderful evening. Take care of your tanks, your fish, your plants, the people around you, and of course, take care of yourself, or you can't take care of all those other things. And I think if half of us thought about that half of the time, that we would have a world that's twice as good. And I'm going to leave you guys there. Cheers, everybody. I'll talk to you next time. I'll talk to you guys on Friday, and there'll probably be a video before that because I have like 4 different ones. I'm deciding on which I'm going to upload. Bye, guys, and thanks again. Members, lurkers, mods, super chatters, you're all so important to me. I really value you guys, and I'm humbled by this community every day and grateful for it every day as well. Talk to you guys later. Bye.